Assalamualaikum warahmatullahi wabarakatuh. So today we as a team going to talk about linear motion experiment that we conduct last month. Let's go. So this is my teammates, Arisha Sofia, Ainul Aina, and me myself is Khairina Shafi'i. Hi, my name is Nur Natasha Khairina binti Ahmad Shafi'i at Laizwan Saufi. Next.
So, hello everyone. My name is Nur Aisha Sofia binti Azmi. You can call me Shah.
Hi, my name is Siti Nur Ainul Aina binti Mat Ilyas.
So this is the index for this experiment, which is linear motion experiment. It has 9 index. The first one is objective, introduction, apparatus, procedure, results, analysis, discussion, conclusion, and last but not least is reference. Moving on to the first index, which is objective. So the objective of this experiment is to use linear air track to investigate Newton's second law of motion. For the apparatus, we are going to need air track rail, blower, pressure tube, glider, flag, photo gates, masses, mass hanger, string and pulley.
For the linear motion procedure is the first one, the linear air track set was assembled as shown in figure 4.1. Second, the pump was switched on to let the air blow through the track for several minutes. The track was balanced by adjusting the screws on the legs of the track so that the glider stays stationary and does not glide to either end when let go. The third one hook at one end and a flag on top of the glider was inserted. The fourth one, the mass of the hanger and length of the flag was measured and recorded. The fifth one end of the string was attached to the hanger and the other end to the glider. The sixth one, the placed maces with a mass of 20 grams on the hanger and put the string over the pulley. Seventh, position the glider exactly before the photo gate. The glider was released at the time shown on the photo gate and the glider was released and the time shown on the photo gate was recorded. 8. Step 7 was repeated 2 times for each maces to obtain the time average values. The last one, the procedure was repeated 4 more times with different masses, which is 20 grams each added to the hanger. This is the results of the experiment conducted.
So we have 4 questions for the analysis of our experiment. The first one, plot a graph of rate force versus acceleration. And the second one, what does the graph tell us? And the third one, do these results occur Newton's second law? And the fourth one, discuss any sources of error. So, you can look at the graph as shown above in our slide. So, for question 2, the graph tells us that the higher the force exerted on the object, the higher the acceleration. This shows that force has a relation with acceleration, which is force is directly proportional to acceleration. This result supports the Newton's second law. Yes, this result supports the Newton's second law, which is F equal to ma. For the last question, Our area that we got from this experiment is students need to hold the hanger and slotted mesh to avoid it from falling. The glider and flag need to be made sure it don't move when the air blower is on before conducting the experiment.
On the other hand, discussion. Newton's second law is one of the fundamental principles in physics that deal with the relationship between force, mass and acceleration. It can be stated mathematically as F equals to ma, where F represents the net force applied to an object, m represents the mass of an object, and a represents the resulting acceleration observed in the object. According to the second law, the net force acting on an object is directly proportional to its mass and resulting acceleration it undergoes. If unbalanced force is applied to an object, it will accelerate in the direction of the force. The magnitude of the acceleration is determined by the ratio of the force to mass. In everyday terms, it can be understood as a stronger force applied to an object results a larger acceleration, and the larger mass offer resistance to change, leading to a smaller acceleration.
The second law indicates the inverse nature of this relationship. If the mass of an object remains constant and an external force is applied to it, the resulting acceleration will be calculated by dividing the applied force by the mass. If the force acting on an object increases while the mass constant, the object will accelerate more. The direction of acceleration will always coincide with the direction of the net force. Understanding Newton's second law is essential in analyzing linear motion. It allows us to predict the motion or lack of motion of an object when particular forces are applied, or understand how varying amounts of force impact the acceleration of objects with different masses in linear motion scenarios.
Based on the data collected, the weight force of hanger and slotted meshes will increase due to the increasing of the acceleration. This proves that weight force is directly proportional to the acceleration. From the plotted graph, it's shown that the relationship between the force and the acceleration is related to the Newton's second law of motion. Newton's second law of motion is a quantitative description of the changes that a force can produce on the motion of a body. Therefore, when the wave force of hanger and slotted mesh is increasing, the acceleration also increasing.
As for the conclusion, the Newton's second law of motion to use linear air track was investigated. Here are some references that we used to do this lab report video. That's all from us. Thank you.